A tokenizer today for a large language model. I'm pretty excited about this because I found some pretty good efficient approaches to do this. We did a tokenizer a couple weeks ago. And hey, how's it going there, Ruchi? Hey, good to see you. Welcome on in. Happy Tuesday. We're building a tokenizer today for a large language model. We're going to build a better one than we built previously. We built a character letter tokenizer. That's pretty straightforward. That's pretty easy. You just take all the letters in your data set, your corpus, and then you find all the unique ones and you've built your vocabulary. Done. Easy. We're going to be doing that today, except for differently. I found a really good approach that we can use with using regular expressions. I remember regular expressions. So we will be building our own tokenizer. I'm pretty excited about it. Well, I think it reduced my token problem, man. Oh yeah, it will. If you make that's the plan. We're gonna make tokens that are bigger. So not just like parts of words. We're gonna make all the this parsing will be one token, right? While will be one token rather than it just being individual letters is what we were doing previously. First like, thank you, appreciate it. Good to have you here. All right, let's get started. All right, so I want to. All right, so where are we at here, LS? I'm going to close this. No, I want to leave that open because if I close that, then I'll have to redo a few things. So LS SRC, we're going to touch the SRC tokenizer.rs, and we're going to start building it. That's what we're going to do. All right. Hey, Soki, good to see you. Welcome on in. Happy Tuesday. We're going to be building a tokenizer today. Let me pull in all of my stuff over to a tokenizer. Source, tokenizer, paste that over there. And then we're going to build encoder, decoder. I'm going to put it over here. All right, tokenizer. Here we go. So we started this yesterday. Hey, Torva, good to see you. Welcome on in. Good to have you here. Happy Tuesday. Okay, so here's our tokenizer stuff. All right. Did we get everything? Is it all the stuff we got? All right, I think that's everything we need. So let's close that and let's get on our way to building a tokenizer. Use regex, I think? I think so. I got your BG song reference. Yeah, you get the background song there. Yeah. I like this song. I like this song right here. It's one of my favorites. We played every single stream at the very beginning. Let me pull this back over here. Perfect. Bit frustrated. Oh no, what happened? You applied for an ML intern. They said I'd get back to you last Friday, but they haven't messaged you, so I haven't read an email to ask them what's up. Hey, Soki, and the initial interview was good. Well, I hope it works out. We were talking about doing an internship today. We're going to build a tokenizer for large language model. That's the plan for today. We're building a tokenizer. We're going to do a character level tokenizer first. Then we're going to jump in and make it a word-based tokenizer. So we're going to make it a little bit beefier tokenizer. All right. So now we can get our dictionary and our tokenizer, and our data is exactly what we want. And string. Is that good enough? Private, it's not, whoops, we can fix that. Hey, Laura Maxwell, good to see you. Welcome on in. Happy Tuesday. Good to have you here. Welcome on in. All right, so let's see, pub. Do we have to say pub here as well? Do you guys know we have to do that? I don't think we have to do that. It doesn't matter because you don't need to pub the implement. You already know the tokenizer is already public through a struct right there. Right there. Boom. Done. Easy. All right. Now we can use our encoder, you guys. Okay. So let's see. Let's see here. I want to see tokens. Tokens equals. It's going to be a tensor. I'm going to say dictionary dot encode data. We'll send the data there. Wait. Here we go. Okay. Then we're going to say print. No. Tokens.print. There we go. That's what we want to do. Because it's going to do a nice little built-in printer. Because it's going to make it look really nice for us. It's really nice. Nice little built-in printer. Thank you, LibTorch. Here we go. Boom. And look at all of our tokens. Look at that. Okay. This is great. This is fantastic. We should probably have reserved the 0 token. So we got to reserve the 0 token as a pad. When word embeddings will start. Oh, we might do word embeddings tomorrow. So we've got here our tasks here. So we're currently on Tokenizer. Tomorrow we'll do embeddings. Today we're going to do a character level tokenizer, and then we're going to upgrade it to a word level tokenizer. Make it looking good. Order operations after launching is super important. It is. Wasted so much time optimizing things that get scrapped. Yeah, you got it. Tokenizer, here, I'm gonna mark this as done, and then we need to upgrade this here. All right, so let's do an upgraded tokenizer. We'll call this the upgraded tokenizer to word level tokens. There we go. All right, let's try that. Okay. Now, I'm going to, should I create a new tokenizer or leave the one that I have now, or just overwrite the existing one? Let's find out. Here, source tokenizer. So this is what we built today. We built the collection hash map, the tokenizer with vocab length. We created a new. This is the faster quick sort. Dedupe. Our encoder and decoder lookups for O of 1 performance. Right there. Right? O of 1. Wow. We just built ourselves a large language model tokenizer. And it worked. It worked really well. Got a couple of to-do items. There's some wrap-up things here. I want to turn this into a word-based tokenizer. So right now I did a character level tokenizer. Right here. And I want to convert this into a different kind of tokenizer. A full word tokenizer, which we can use regex for. Okay, where are we at here? So I want to implement this approach here, which is pretty, is that the one I want? The one I really want? Yeah, I think I want to do that. All right. Regex, yes. Okay. So this will be a new encoder. This is the new encoder. So we can capture all the data. Let's think this through really quick. So I want to, what would we call this? Vectorize? No, we need to parse it. We call this the parser. So let's create a new parser. And it's not a public parser, it's a private parser. So function parser, self, and then we grab our text, which is gonna be and string. And the output is gonna be something that I can use here. A vec of strings, maybe. Okay. I think a vec of strings, right? Vec of strings. Maybe. Maybe, right? Okay. Then, I guess we could do answer. That might be easier. String as string, which is gonna copy that out. So let me type that in. Okay, so this will be our regex. Let matcher. Let's call it matcher equals regex. Hold on, is it re? Where is it? No, it's called regex. Okay. Regex new. Call this a. What was it? I know there was a pipe dot \w. Is that right? Oh, we got to throw an R at it. Okay. There we go. Perfect. Okay. Use of unresolved module regex. Cargo add regex. See if that works. So we're not going to be using lifetimes. Nope, not going to happen, Rust. You don't need it. It's not necessary. All right. I want to get this parser written and solved for right now. This is what I want to do. I want to solve for this. And I really want this to be a string. It can be a string. Yep. And we collect. And then we say to string, right? No lifetimes. We don't have to deal with lifetimes anymore. Done. Easy. Now there's not a trait bound that we've got a problem with. Regex match due to unstarted trait bound. Is it going to give me any information on this? Okay. We need a smidgen of help. Let's see here. This is when we jump in, you guys, and ask the AI for just a smidgen, because we only got 9 minutes. We could thrash on the keyboard for a while, but we only got 9 minutes. Still learning Rust. Yeah, the Rust book. Yeah, there you go. What am I doing wrong? I did say toString. Use .as stir here. Oh, are you sure? Oh, got it. All right. Oh, we were like one. We were off by 1. Look how easy that is. All right, there we go. We did it. Okay, so I want to try this out before we head out, you guys. We're going to try this out before we go. Let's go to our main file and let's see if we can get our parser to do something here. And our parser is going to return. What's it return? I guess we're going to say public for now because we want to use it. Vec of strings. Okay. Let test equals vec of strings. Our dictionary dot parser, and we're going to put in our, do we have test string? Here we go. And we're going to print this out. Print ln exclamation point the test. Okay, here we go. What do you mean? What do you mean? Cannot be formatted with the default formatter. Oh, okay. Well, then what if we made it extra special? Hey, look at that right there. Although it gave me letter by letter. It gave me letter by letter. And I want this to be a parser for word level. So it didn't. Hey, Donut Dude, good to see you. Welcome on in. Happy Tuesday. All right, Kyle, here we go. We got to turn that into words, you guys. I want to see this as some words. I need it to see as basically 1, 2, 3, 4, 5. It's going to be 5 strings. It's going to be 5 strings, you guys. So why this not work? Did we mess it up? Here we go. Here we go. Right there. Is that... Yes, we did. We messed it up. Okay. You guys, you're supposed to say, hey, Steven, you messed it up. Here we go. 5. There we go. That's what I'm looking for. We tokenized. We appropriately tokenized. We did it. Okay, this makes me really happy. Now, let's see if we can use our parser and our tokenizer really quick. Let's use our parser and our tokenizer. All right, so when we build the dictionary, we need to, instead of doing this, we need to do something else. We need to, right? Okay. So we need to run our parser right here on the new. All right, so let tokens, it's not chars anymore. That's gonna be a problem. Okay, we might have to save this tomorrow because we're not doing chars anymore, we're doing strings. Although we could probably fix it really quick, right? We could probably fix it really quick. We're gonna call it words equals, it's gonna be a vec of strings equals self.parser. Yeah, I thought we were going to non-standard approach or some optimization. Yes, we are building a more advanced tokenizer. Basically, we're gonna make it a real beefy one. Rather than a letter by letter, we're gonna give it some very specific meaning. These words that are gonna pop up in the right spot will have dedicated embeddings. They're going to have their own dedicated embedding. Rather than being shared across the meaning, across a whole bunch of shared embeddings, it's going to be dedicated. So that means our embedding model is going to be a little bit bigger, it's just fine. And our token size will be smaller. So our vocab size will be smaller, which is going to allow the model to learn better. It's basically it's very common to do this approach. So that's what we're doing right now. And we do have to get going, you guys. We're going to finish this tomorrow. We'll finish the encoder tomorrow. We'll get it to word. So we did character level encoding. So we did a really good job today, right? We did char level, character level success. Is our training AM? Okay. Let's see. Tokenizer, char level done. We need to finish the word level, right?